Our next speaker here has 35 years in tech. It started off at an 80 by 24 character screen. Then he traveled from there through professional comedy, back to computers, from terminals with serial cables to the supercomputers that we all carry in our pockets today. They're also a bass player in the tech parody band The Linebreakers, and they're here to tell us what we might all be doing in the year 2060. Welcome, Rendle.
Yeah, professional comedy, hence the handheld mic. Hey, it's great to be here. Hello, there you are. I was wondering where you were. Very distinctive voice. Yes. Actually, I love coming to Malmö. I get to come here a fair bit for various different conferences. It's actually where my first ever international conference was back in 2013. So, yes, this is Futurology for Developers. I think I've been doing this talk, different versions of this talk, because obviously the past changes and then the future changes and everything, but for like 10 years now. I think I first did this in 2016, so it's been updated a lot, and so this is the latest version. Big changes this time, obviously, but let's start at the beginning. Do the thing. I'm gonna. So yes, this was my first server. When I started my job at the age of 16, in end of 1989, and we had a Tandon 286, and it had like, what are we saying, 2 megabytes of RAM and 150 megabyte hard disk, and 8 programmers writing, it was called ESQL-C, and it was basically just standard C, ANSI C code, but you could write SQL statements and put them in dollars, and then there was a pre-compiler that would turn that into C ISAM calls, and then it would compile and link the whole thing. And the compile and link for the application we were all working on took about 3 hours, and nobody else could do anything else on that machine while it was doing those things. We didn't have anything else we could be doing. We had a table tennis table, and if you broke the build, then you had to stay late to fix it, so it was ready for the next morning. And if nobody broke the build, then we literally got to go home. It was brilliant. Yeah, it's like 5 hours work a day. So, and that's the chip that we're talking about here. It ran at 8 megahertz. It had 1 core. Because the idea of, if you wanted multiple processors, you had to like stick multiple processors into a board that supported them. 134,000 transistors, and these were things that you could actually see with like a really good magnifying glass. You could see the transistors on the chip. And you're probably familiar with Moore's law that says the density of transistors and therefore the performance of the chips doubles roughly every 18 months. And ever since then, the people who make chips and the people who make the machines that make the chips have been trying to keep this true. And we got to a point where we couldn't really fit any more transistors into a single core, so we went multi-core. And so now we have like the Apple M5 Max. This thing, so we've gone from 134,000 transistors that you can see with a magnifying glass to estimate 150 billion transistors on this thing. The version that's got 128 gigabytes of RAM actually on the chip, and it's got 74 cores. It's got like 16 CPU cores, 18 GPU cores, 40 GPU cores, and 16 NPU cores. It's insane. This is a rough idea of a comparison in size of those transistors. If the one there was the transistor that was in the 286, then that one on that side, it's. Is this just not working now? We're just going to do this instead. There you go. It is there. It's a pixel. It's 1 pixel, And that one has been very specifically sized so that that is the correct ratio. If you want, I can send you the slide deck and you can do the maths. This was the 2 megabytes of RAM, that's what that looked like. And now we have, that's a 32 gigabyte DDR5 8800. Brilliant example of how this talk changes over time. I would have said, this is ridiculously cheap. But it's not, is it? That's like more than its weight in gold right at the moment, because Anthropic and OpenAI are stealing all the RAM. This is my favorite one though, storage. This was 150 megabyte. This is a full height, 5¼ inch SCSI hard drive. This thing had like 8 platters spinning inside it. If you wanted to move the machine, like even if you wanted to tip the machine over by 5 degrees, you had to park the heads on the hard disk. Otherwise, that was it. The disk was screwed and you would never be able to boot it again. If you dropped that on your foot, it would break bones. Now, you can go on Amazon and for a couple of $100, so that's a London bus for scale. Now you can go on Amazon and you can buy a 4 terabyte micro SD XC, whatever the hell it is, card. And that, in terms of, it's about that big. And that's 40,000 times more storage in something. This was a Wyse 50 terminal. This was what I was using when I first started. We actually had Wyse 60s. Those were really nice. They were more square. But no, this was green on black, and the Wyse 60s were orange on black. It was really luxurious. This was the first laptop that we had, and this cost an absolute fortune. And it had like a non-active screen, and this was the thing where I deleted a customer's database because I couldn't tell whether I was on the laptop or their server, because basically the same hardware. This is a modern laptop. It's completely ridiculous. This is a printer, and that's a dot matrix printer. There is some audio, but I forgot there was audio. Sorry, that's on me. Used to make that noise. And then, back in 1990, there was stuff that didn't even exist. We didn't have the World Wide Web. I spent the first 4 years of my career working without the World Wide Web. If I wanted the documentation for ESQLC or Infomix 4GL or the Infomix SQL database, I had to go to the bookshelf and get the ring binders that had the documentation in them, and then turn to the page that I wanted and then find out that it wasn't there because someone had just taken those pages out and hadn't put them back. No World Wide Web, no Wi-Fi. The terminals were like all wired into the server using something called a Chase 88 board and RS-232 cables, which it was also my job to make with a soldering iron, and I have the scar under my middle fingernail from where I dropped a blob of solder on there. The cloud, that was not a thing. Obviously, if you wanted a server, then that took like 6 to 9 months to get a server because you had to go to somebody who made servers and order one, and triple entry bookkeeping and everything. Touchscreens, no. Just, no. Keyboards, that was it. I still remember when we started upgrading people to Windows. And I would turn up with like half a dozen Windows machines and Windows 3.11 or Windows 95. And even when we were doing Windows 95, we would be giving this to people and giving them the mouse, and they would just go, what do I do with this? And I was kind of like, one day everybody will know how to use a mouse. And now I have 2 kids, and if you give either of them a mouse, they'll look at it and go, what do I do with this? That the mouse was like so revolutionary, but also only relevant for about 30 years. That's how fast shit moves. So yes, touchscreens. This was the first attempt at a touchscreen that really got noticed. This was one of Apple's very, very few misfires. You know, the trope that Apple just waits for somebody else to get the technology most of the way there, and then they jump in and perfect it. It's because of this. This is what happened when Apple tried to innovate. It was hilarious. It was the message pad, it weighed over a pound. It was heavy as hell. It could not keep up with you writing on it at all. It was just a very, very, very shonky thing. And it then took Apple 13 years before they tried again and then nailed it with the iPhone, which I think we can probably all agree did change the world in some good ways and some bad ways. So, over these years since then, we have got faster, we have got smaller, we have got lighter, we have got preciser. That's more precise. We have got powerfuler. It gets worse. And we have got connecteder. But yes, as Freddie said when he was introducing me, there is more processing power in my watch than existed in the world before 1970. That's a statistic I like. You think we put people on the moon in 1969, we had all those mainframes, all those sorts of things, and your watch contains more transistors and more CPU and GPU power and NPU power than there was in the world before, like 3 years before I was born. So let's extrapolate from there. This is my new hobby. It's not new, I've been doing it for 10 years. But let's have a guess at what things are going to be like. So, Moore's law up to 2060, would we have quadrillions or quintillions of transistors? Probably not. We are already getting to the point where more transistors is not solving the problem. And so we're making them as small as we possibly can. The M5 Max chip, this is the latest sort of best general purpose CPU, GPU, NPU. That's built on a 3 nanometer process. This year they're rolling out the 2 nanometer process, so the M6 will probably be 2 nanometer. The M7 will probably stay on the same thing. Then the M8, we might get down to the 1. It stops making sense. By the way, nanometers at this point, so when it was 1.5 micrometers, that was actually a rough indicator of how big each individual transistor was. These days, it's just a number, and they stick nanometer on the end because they don't have any other unit. But it's got nothing to do with how big these things are. Each of these transistors is like 3 atoms. So this is what they look like close up. So we're looking at other ways to make processors, other ways to do this kind of logic processing and storage and so forth. So we have silicon germanium, that's kind of the current state of the art. This is how they're doping silicon to make it more malleable and precise. Graphene and carbon nanotubes, these have been like going to save the entire world ever since somebody first stuck some sellotape onto some pencil graphite and peeled it off and went, I have revolutionized physics. We've got photonic, and I'm going to come back to this later because photonic processors up until now have been big unwieldy affairs with lasers and stuff, but there's been a development that I will come back to. Organic, this is weird, because obviously the most powerful computer that we know of is this, in there. And if we could figure out how it works and then make synthetic versions of it, and we can grow stuff in petri dishes. We can grow neurons and brain cells and so on. There's a whole ethical thing there. Quantum processors, going to come back to that a bit later as well. So yeah, these are the things that we're looking at to try and keep accelerating forward. I love this statistic. It has. Yeah, here we go. So a 64-bit quantum computer, each 64-bit register, or 64-qubit register, can hold 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,616 different values simultaneously. And then when you read it out, it collapses that down to the right one. And I swear to God, the way they think it does this is that that computer exists in that many different universes, and then they all share the right answer. They believe the many worlds version of quantum mechanics, which is just nuts. So, current trends. The next slide, this was true before my wife kicked me out. But anyway, don't worry, it's a good thing. Happier now than I've ever been. Can you tell? So, this was a non-exhaustive list of the things that were connected to the Wi-Fi in my house. The doorbell was connected to the Wi-Fi. The washing machine was connected to the Wi-Fi so that I could get a notification on my phone when I was in Malmö telling me that the washing had finished. And I could tell that, 2 days later in Malmö, I would send my wife a text message going, "You probably need to run the washing machine again. It's going to be smelly by now because you didn't take it out." These are the things that aren't really computers. And these things, that's just weird. Who's not been able to read a book because their book ran out of batteries? Or just crashed because of an update? Yeah. Who's just, I don't know. This is a Raspberry Pi 5. Again, these have suddenly shot up in price because of the RAM shortage. But this thing, the Raspberry Pi, I still remember the original Raspberry Pi coming out, and it was not very powerful, but you could do stuff with it, and it had Linux, and it had a desktop, and you could write Python code on it. The Raspberry Pi 5, this is you get the 68 gig or 16 gig version of this. That will do most of the stuff that the majority of people want. People don't need MacBook Airs or whatever. A Raspberry Pi 5 with 8 gigs or 16 gigs of RAM, it'll do your web browsing, you can watch YouTube on it, you can play most of the sort of simple games on it, you can do all that sort of stuff. This is the Raspberry Pi 02W, that's got wireless and Bluetooth built into it. That thing is nuts. That will run Linux. And you can log into it and you can do things, but you can also run it off a pair of AA batteries for 6 months, and you can build stuff with it. This is the NVIDIA Jetson Nano. This thing has 67 TOPS, 67 trillion operations per second on its GPU and tensor cores. And you can build edge AI things. This will do image detection, person detection, image recognition, all sorts of mad stuff. That's like $250, I think you can get one of those for. And you can build AI that actually runs at the edge. And you've got hummingbirds and all this sort of stuff. The reason I think these things are important is because one of the things that is a real problem, and even more so today, is the energy use. This chart, woefully out of date. I couldn't find an up-to-date one. This was the energy that IT was using before we started filling data centers with GPUs. So that we could do inference and training and whatever else. So this has just skyrocketed, and we need to do something to bring that down. And one of the things we can do to bring that down is stop making software kind of bigger and more bloated and make it more focused, make it do the things that people need it to do, and sell them Raspberry Pis instead of selling them Dell Latitudes with like huge 64-bit Intel CPUs and everything else. We default to running things on x64-based hardware in data centers. You go in and you say, I want a C2 instance or a T2 instance or whatever it might be. The vast majority of the stuff that we're running will run quite happily on an ARM-based CPU that will use 1/10 of the energy of the x86-64 equivalent. So when you are deploying things into these data centers, please start defaulting to ARM, because it will reduce the power consumption. It's only a little thing, and the cooling, and it's It's fractional, but it's fractional across all the data centers in the world, actually adds up to less heat. If you've got kids, by the way, Make Code Arcade, this is a Microsoft thing. It's really good. It's a great way to get kids into coding, but not so much coding as creating, as building. I got my son into it. He created, it was sort of like Pokemon, but with Zelda graphics, and it's a kind of drag and drop thing like Scratch, but you can click a button and it switches to Python or JavaScript, and then you can kind of like go through the code, and then you can switch it back into the graphical thing. But the thing that he built, when you zoomed out so you could see all the graphical ifs and whiles and whatever else, it just looked like static. It was more than 10,000 lines of Python when you converted it to Python. It nearly crashed the little website. You can buy them little consoles that they can then put their game on, and they can take that to school and they can show their mates the game that they made. So yes, and Adafruit Pi Gamer, that thing is literally, you put it on your lanyard, and it goes there. And the kitten bit, I love this one, that's so cute. Okay, let's think about stuff like that is now primitive technology, like laptops were back in 1990. So the one that I'm most obsessed with is the user interface. So for as long as we can remember, the user interface to talk to a computer has been a rectangle with a keyboard and potentially a mouse or a touchpad, or sometimes you can just touch the rectangle directly. We're starting to be able to talk to it. But the user interface is going to be changing hugely over the next 35 years. Come on. So yes, who's seen Ready Player One? Yes, fantastic movie. Everything happens in virtual reality, and you can look like whatever you want to look like, and all this sort of stuff works. And we are at the primitive technology stage of virtual reality. So we have things like the Rift or the HTC Vive, I think this is. This connects to your PC with 2 cables, and then you've got like detectors set up all around the room, and so we're iterating on this to make this better. And not pictured, all the cables that are necessary to make that work, and of course the insanely powerful computer with a GTX 5090 GPU in it that you need to sustain a frame rate that will stop you getting motion sickness. Much better, MetaQuest 3. This is quite a lot cheaper. It's got full color pass-through. We've got my son has one of these, plays Beat Saber on it, almost exclusively Beat Saber. It's a Beat Saber machine. You know what? It's worth 400 quid just to use it as a Beat Saber machine. Although, you know, vest and shorts, that's your workout for the day. It is it's so good. Then you have Apple. This is the Apple Vision Pro. They've recently released the Apple Vision Pro 2. Remember talking about Apple's one misstep, the message pad? Yeah. Vision Pro is not going well. There was a very brief, maybe 6 weeks, when if you went out for a walk in Silicon Valley, you would see half a dozen idiots with one of these strapped to their face, like skateboarding. But no, it needs to get smaller. The thing is, though, on the inside, I honestly believe that this is where we are headed with this. There is going to be something that is light enough and comfortable enough that you can put it on when you wake up in the morning and keep it on and then take it off when you go to bed at night. I'm not one of these people who goes, oh, let's replace our eyes with eyes that have this built in, or the Black Mirror scenario. But I don't know. It might be glasses. But I'm also thinking it might just be like a baseball cap with laser projectors built into the thing that just beam very, very low-powered laser into your eyes. Anyway, I don't know what it will look like. What I do know is that the Apple Vision Pro, big uncomfortable thing that you strap to your face that makes your face sweaty, and also has those really disturbing eyes, like the pass-through eyes, so other people can see those aren't your eyes. No. I've had a conversation with somebody who was wearing an Apple Vision Pro, and then we switched, and they had a conversation with me, and both of us agreed, that's not our eyes. I don't know whose eyes they are, but they're not ours. Scary. But it took Apple 13 years to go from the message pad to the iPhone. So Vision Pro came out 3 years ago. We've got another 10 years. In 10 years, what is the Vision Pro going to look like? It could look something like this. And when I first made this slide, it was a different headset on the other side, but it was those little round glasses. Because just think back, that 150 megabyte hard disk that you could literally use to hold a door open. And then the 4 terabyte micro SD card. You think about the computer that they used to land Apollo 11 on the moon, and my wristwatch, okay? 10 years, I honestly think we can get this down. We're already quite a long way along that. This is the Ray Neo X3 Pro, and if you look closely, you see, is this a laser? Yes, it is. So little rectangle in the glasses there. That is the active bit. That's a waveguide. So this is nanotechnology. They've etched a 4K screen into the glass with like channels that the photons can pass along, then bounce out through the waveguide into your eye and create an image. This has a 30-degree field of view. Okay, so from the top left to the bottom right of that display is a 30-degree area of what's in front of you. It's very, very small. You basically have to be looking directly at whatever isn't there in order to be able to see it properly. These are the Meta Orion glasses. These are you can only try these by going to Meta's office and pretending to like Mark Zuckerberg. And so people, sorry? It's, no, I don't want to think about that. Shh, now. You've ruined it. But no, these have a 70-degree field of view. That's like the entire thing of the glasses. That's pretty good. This is something that exists now. It's something that has the processor and the artificial intelligence, and everything is on board. It's got a battery life of apparently 4 to 6 hours. And you know, it's pretty good. This is, I don't like Meta, so what I really want is like Steam to release the frame, whatever the thing is, so that I can get something that isn't the Meta Quest 3. These are the glasses that Google are working on for the prototyping of Android XR glasses. They're working with XReal to make these. But this is where user interfaces are going, augmented reality. I firmly believe this, and it's going to change the way we interact with computers. So I'm working on something at the moment, and I'm hoping to have a functioning demo at some point this year, ADHD permitting. Anyone seen His Dark Materials or read the books or anything? If you haven't seen it, it's an alternate reality where every single person, their soul is on the outside, and it takes the form of an animal that goes everywhere with them. And everyone has different animals. Up until adolescence, it can take whatever animal form it wants, and then when you reach adulthood, it chooses a permanent form. People have tigers, snakes, monkeys, all sorts of different things. And so this is Lyra, this is her demon, they're called, with an A, like the sub-process. And this is what I'm building. It's an AI that runs in your house, so it's not using cloud AI, it's not using Claude or anything like that. And then it's using a Cloudflare tunnel to connect to your phone, and then I'm using augmented reality AR kit, starting with a bird, that you can hold the phone up and the bird kind of like flaps around. It does edge detection, it can find furniture, the bird can stand on furniture, and you can have a conversation with it. This is roughly where I think we're going to be going to with the user interface. Certainly, we're going to have screens floating in space. We're going to have things that we can interact with like that. We're going to have reminders that just pop up there. And we are going to have the best fucking ad blockers in existence, because you just know that you are not going to be able to walk past the 7-Eleven without having your entire field of vision filled up with all the things that you can get 3 for 2. So, if you want to build in this space, going to say required skills, and then we'll come back to that later. 3D graphics and modeling, spatial design, so figuring out how to lay things out in a way that is pleasing. Maybe study feng shui, and new interaction models. So people are going to be talking to these things. They're going to be sort of using their hands. We have hand gestures and so forth. There are SDKs for all of this kind of thing built into Unity, built into Unreal Engine. If you're just building for like iPhone and iPad, then you've got the AR kit in Swift and everything else. So yeah, Unity is free, Unreal Engine is free, Unity's slightly easier if you're a C# programmer, Unreal Engine is probably slightly easier if you are not a programmer because it has blueprints, which is like a drag and drop thing. Asset Store is where I got a pack of birds for £33, I think it was, to use as my prototype, and then there's some other things there. And if there is a web version of this, obviously, because there's a web version of everything. There's aframe.io and WebXR, which is how to do mixed reality with that thing. And Snow Crash, if you haven't read Snow Crash, it's a little bit problematic in places. Some of the more, this is like a 90s book. It was fine at the time, but you might have to kind of like go, oh, all right, well, yeah. But it's the vision of augmented reality and how we interact with computers, I think, is bang on. Okay, next thing, 3D printing. Who's got a 3D printer at home? Yeah, and who actually uses it on a regular basis? Because I bought a bass guitar. The first proper like bass guitar I bought didn't have a comfortable place for me to put my thumb, and so I spent like a weekend designing a thing that I could then attach to the guitar so that it would have somewhere comfortable to rest my thumb. And it was brilliant. All I had to do was think about it. The 3D printer wasn't very good, but once I'd got it right and I knew it was in the right place and I could play with it, I just sent that file off to a company, and 2 days later I got like high resolution 3 different versions in different plastics sent back to me. 3D printing is amazing. This is what it used to look like. This is the first ever 3D printer, the 3D Systems SLA, Stereolithographic Apparatus from 1992. And this thing cost $100,000, and it wasn't great, but it worked. But then think about the dot matrix printers that we were using around the same sort of time. We had laser printers as well, but running the laser printer was really expensive. So I remember when we were doing code reviews, we would print all the code off on the dot matrix printer, 120-column dot matrix printer, and then just spread it out on the boardroom table and go, yeah, no, what's this subroutine here? No, can we optimize that? If you rewrite that in raw assembly, then you can make it more efficient. These days, well, there was Darwin, which was the first kind of what they call RepRap, the self-replicating 3D printer. If you had access to one of these and some rod stock, you could print the parts you needed to make another one, and then just join bits together with the metal rods and attach the necessary motors and things to it. This is what Amazon looks like now when you search for a 3D printer. You've got things like the DaVinci Junior, which looks a hell of a lot like the original iMac, and I don't think that's an accident. If I were Johnny Ive, I would be wanting a slice of that action. This is the DaVinci Color. This uses special PLA and just has inkjet style ink in it, so it colors the print as it's printing it. This is the Form 2. This is basically the 3D printing equivalent of a laser printer. It is using a laser to cure resin and producing insanely high quality prints. This is the Bamboo Labs X1C. This is literally, you can take this thing out, you can stick it on your desktop, you can push a button, it sets itself up, you can put 4 different rolls of PLA or whatever onto it, and it will print things in multiple colors. And you can print stuff like this. And so if it took us however many years, it says 20 years to get from that dot matrix printer. That is actually the dot matrix printer that we had in my office, by the way. It took us 20 years to get from that to, you can now get a full color, high resolution inkjet printer that is small enough to stick in your carry-on luggage so that you can print the photos off while you're on holiday. But we can also print gadgets. This is the state of the art at the moment in Silicon Valley. They have 3D printers that have got metal and various other bits and pieces in them. They can print a remote control for a television. The only thing that you need to put in it is the batteries. Everything else is 3D printed. The infrared emitter is 3D printed somehow. So obviously this is got a ridiculous range of materials that are available for it to pump in there, and there is some assembly required. It doesn't come out fully assembled, but this is almost to the point of like manipulating the individual molecules and so forth. That's where we're headed. We can 3D print food. This is a 3D printed steak. It does not taste good. But if it was a choice between this and not having any protein in your diet, you would probably choke it down. But we are going to get to the point, you know, there are 3D printers for pancakes now. You can actually buy a 3D printer that will print your face onto a pancake so that you can eat your face. That's one of those solutions looking for a problem. It's just, but yes. So I'm kind of thinking this century for this prediction. I do think we're going to get somewhere close to, for God's sake, this is killing me. Tea, Earl Grey, hot. You have to order it in that direction because otherwise the machine will just get hot and start guessing what you want. And no, don't say that thing. Okay. This is the elephant in the room. We've been waiting for me to get here. I'm probably going to finish on this, rattle through a couple of bits at the end. AI. So the history of AI, well, we had the Turing test. Alan Turing proposed if you could be having a conversation with something in another room, you couldn't tell whether it was a human or a computer, then that thing had passed the Turing test. McCarthy and Minsky, they called a conference, the Dartmouth conference. They all got a bunch of people together and they said, we're going to build artificial intelligence and it's going to be ready by 1960. No! The Lighthill report in 1973 concluded that artificial intelligence would never be able to beat a moderately good human at chess. The 1980s was expert systems. Let's not talk about that. We wasted a decade. In the 1990s, Deep Blue beat Garry Kasparov at chess. Not a decent, the best chess player in the world. Obviously now we have Magnus Carlsen, but Magnus Carlsen could not beat the sort of generally available chess program on the hardest setting today. It's ridiculous. In 2002 was when the Roomba came out. This was a machine that would learn the layout of your house. I mean, not my house. The layout of my house changes depending on how long it is since I last cleaned. But if you have a relatively clean house, then the Roomba can keep it even cleaner. And that's been around for 25 years now. 25 years of the Roomba. That's unbelievable. Boston Dynamics making terrifying dogs. That literally, there's a Black Mirror episode where somebody is being chased by a robot dog, and somebody at Boston Dynamics went, oh, I'm going to build that. The person escapes with the dog by going through a thing and locking a door behind them. The dog's just saying, and then she's trapped in the room like Cujo. And Boston Dynamics went, oh yeah, no, that is a design for it. Put a robot arm on top of it. Do not build the torture nexus. Anyway, Watson, IBM put Watson up to play Jeopardy against the two best Jeopardy players ever. And it did it properly. It listened and transcribed the questions, found the answer, and then phrased the answer in the form of a question, which is the stupid Jeopardy thing. What is blue is like the correct answer to what color are my eyes. So yes, but it won, by the way. 2011, Apple released Siri. 15 years later, it has not improved at all. We keep getting promised Apple Intelligence, but yeah, no, it hasn't happened yet. But we'll come back to that. 2014, Amazon released Alexa, hasn't improved at all. 2014, driverless cars, they have improved. We're now at this point where people, oh no, driverless cars have killed people. Yeah, you know what else has killed people? Driven cars. A lot more. Our kids are going to be like, you drove the cars yourself? Yeah. Didn't people die? Oh yeah, hundreds of thousands. Yeah, it was worth it. Didn't want to walk to the shop. Google Assistant, lol. When Deep Blue beat Kasparov at chess, the response from people was, it'll never do Go, though. Go is an infinitely more complex game. AlphaGo beat the world's best Go player at Go in 2016. And then a year later, AlphaZero, which they didn't even teach to play Go. They created a machine that could learn, and then they went, play a game with AlphaGo. And AlphaZero in 24 hours was able to beat AlphaGo without any kind of how to play Go programming in there at all. And they are now, having kind of gone, yay, we've solved Go, they actually have turned it to something useful. There used to be a thing called folding at home. It was a screensaver you could put on your PC that would do protein folding, because it's a massively complicated problem, and hugely distributed processing was seen as the best way to solve it. And then they built AlphaFold in 2020, and it did the whole thing, like overnight, because that's what we can do then. In 2022, ChatGPT came out and said there were 18 R's in the word strawberry. And we all laughed, but now we have Claude Code. Who's using Claude Code? Yes, absolutely nuts. We even have things like Qwen 3.5 was released last week, a couple of weeks ago, and this thing will run on your machine if you have enough resources to do that. So it's 808 gigabytes, the weights, and then whenever you look at the size of the weights, you need roughly 20% more than that memory for things like your key value cache, your sort of working memory, all that kind of thing. And so we want something that has 970 gigabytes of RAM. So let's just round it up and call it a terabyte. Remember that thing that I was using back in 1990 with the 2 megabytes of RAM? And now we're talking about something that has 500,000 times more memory than that. This seems ridiculous. The idea that you would have something, have access to something that has a terabyte of RAM, but I think there's a very real chance you will be able to buy that thing for about £15,000 later this year, because Apple are going to release the M5 Ultra Max Studio. The M3 Ultra has half a terabyte of RAM. You can run some pretty big models. You can run the 270 billion parameter version of DeepSeek on that, and still have enough to be playing a game at the same time. They are going to release a 1 terabyte Mac Studio. It might not be this generation, but it will be next year or the year after if it's not. And then we'll go to 2 terabytes. And then you think about how quickly that takes to filter down to everybody. And by the early 2030s, this will be the entry-level machine that you just buy and stick in your house. So, you are not programmers anymore. Anyone in here who thought they were a programmer, you're not a programmer. It's questionable whether you're a software engineer. I think what you are is a software builder. I think you're an application builder. I think you need to let go. Okay, so who's a .NET programmer, a C# programmer? Who's a Java programmer? Who's a front-end programmer with JavaScript? Who uses React? Anyone do Swift? Anyone do C++ or C? Okay, anyone do Python? Yeah, none of you are that anymore. You are just a software builder. It doesn't matter what the programming language is. If you know one programming language, you can read and understand any programming language because they are just if statements, variable assignments, and loops. That's all programs are. Routines, subroutines, all this sort of thing. So now you tell something to generate the code to achieve a task, you break it down for it, your programming language now is Markdown, okay? And I'm sorry, you just need to be okay with it. I think we are heading for the end of applications because why do you need Excel? Excel, Word, PowerPoint even, these things are means to an end. And we can just go straight to the end. We can build AI systems that just go straight to that end point, that you can just go, how much tax do I owe? And it just gives you the figures. You don't need to put all your receipts and everything else into a spreadsheet and work it all out and set the formulas. It'll just say, you owe this much, and you can pay it. Or you can go, get me out of it, and it'll do that too. And the thing that worries people the most about this is they go, well, if I'm now 10 times more productive, 20 times more productive, won't they fire 19 of us? And it's like, no, because the amount of software we need to get to the desired state of the world is ridiculous. We can just keep building it and building it and building it until everything is automated, until you don't need to send people down holes in the earth to get the cobalt out, until you don't need to send people out into the fields to pick the crops, until you don't need to send people into power stations to generate the power, while we're still building things that are using too much power, while we're still using fossil fuels. There are so many problems that we can solve with technology. So we don't have enough people, even with the AI supplements. We just need to set our sights higher and strive more. So in the future, we're going to have quantum computing. That's going to be a thing. It's mainly going to be used for cracking cryptography. So now we have post-quantum cryptography. One quick thing about that, it has kyber crystals and dilithium crystals. And I just love the fact that somebody is trolling the sci-fi nerds by mixing those two things. That's just brilliant. So you can start with that. I wrote some quantum code the other day. Well, I say Claude wrote it. So yes, nanotechnology, we are going to get to the point, remember I was talking about 3D printers earlier on, we're going to get to the point where we can manipulate molecules. Remember I talked about photonics, huge great things, optical metasurfaces, so this is using the same technology we use to create silicon chips, but using it to etch glass so that we can control the way light travels through the glass. It's insane, and then you can build a neural net that does image recognition into 25 layers of glass film, and now they've figured out a way to make these programmable. So you can change the etching on it without having to use the thing to re-etch the whole thing. This, you can run the Qwen 3.5, the full 900 billion parameter, whatever it is, version of Qwen 3.5 can run on a chunk of glass that you could eat without hurting yourself as long as you rounded the edge. It's literally a postage stamp. Remember those? No. Trust me, that used to be a thing when I was a kid. Current nanotech research, we have nanomaterials, bottom-up, top-down, functional, biomimetics, and speculative stuff. That's like the optical metasurfaces and making things from molecules. You want to get started with that, you will need a bachelor's degree, a master's degree, a PhD, and a research position at a good university. I'm going to recommend another Neil Stephenson book, Diamond Age. This one is less problematic, and it is possibly my second favorite book in the world after The Hitchhiker's Guide to the Galaxy. And so then if we stretch out 3 years' time, this asteroid is going to get closer to us than the moon. And if, politics, I'm not doing that. 2039, we will have people on the moon full time, and hopefully they will be generating power and beaming it down to us using microwave lasers and all this sort of stuff. And remember the stuff, all these problems that we need to solve, all these problems that we as engineers can solve with our little AI sidekicks. This is where we want to get to. We want to get to 2060. We want the entire world to be run by robots for us so that we can dedicate our time to learning, philosophy, art, theatre, drama, whatever we want to do. Just make the world a better place and strive to make each other happier, all watched over by machines of loving grace. Thank you very much.